Welcome to this webinar on AI security and testing tools, where me and my co-hosts will present some of our experiences with security of AI applications and the use of testing tools. So who are we? I am Benjamin from the Alexander Institute, where I'm a security architect and work with many different aspects of security from both theoretical and to practical issues. With me today, I have Panos from PrivacyMate, which is a startup making an AI agent for automating compliance workflows, and Emil Petersen from RiskFinder, a startup making an AI product aiming to assist with business continuity plans and risk assessments of systems and organizations. The knowledge we'll present today is developed in the project Security by Design, that's designed for AI startups, secure and scalable AI agents, where we at the Alexander Institute investigated several aspects of security challenges faced by AI startups. And this we did in collaboration with, in particular, PrivacyMate. This is funded by Direct, the Digital Research Center Denmark. Very briefly about the Alexander Institute, where I'm from. We are so-called GTS Institute, which focuses on helping companies and organizations apply state-of-the-art IT research in practice. So let's get started with the actual content. So first, this is the title of the webinar, the AI security and testing tools. And the agenda for today will be, first I'll talk a little bit about some motivation for using testing tools. Then I'll talk about some common AI vulnerabilities. Then I'll give a concrete example of an AI vulnerability that you might face in your applications. And then I'll go into a couple of examples of testing tools, which we have applied together with PrivacyMate and RiskFinder. And then finally, we will get some input from Panos and Emil, who will talk about their perspective and experiences with AI and AI applications and the security issues that they have faced. Yeah, so first of all, we have a little bit of motivation. So why test AI applications? Well, AI applications use AIs, which have unpredictable behavior. So testing for when different kinds of edge cases can be a good idea. And also these kinds of AI applications, they have some new attack surfaces, which I'll also come back to in the next section where I talk about some example vulnerabilities. Testing allows developers to keep up with a new behavior and react to it. So if you switch to a new model or you implement some new feature, then if you have a good amount of tests, then you will be able to adapt and see if some new issues crop up. And if you have some lightweight or easy to set up testing frameworks, then this can allow developers to focus on features and functionality instead of having to worry about security and these kinds of issues. Good. So now I will discuss a couple of vulnerabilities, some very common vulnerabilities. The categories I will talk about are from this. There is these different kinds of lists of vulnerabilities are made by different kinds of organizations. For example, this organization called OWASP, they've made a list of the top 10 most common AI vulnerabilities. And I'll present 3 of these, the 3 I consider important and also which are like, I think, some of the vulnerabilities that you can actually catch using testing and testing tools. So the first one and the most important one, I think, is prompt injection. So just here is the definition from the person who coined the term. Prompt injection is a class of attacks against applications built on top of large language models that work by concatenating untrusted user input with a trusted prompt constructed by the application's developer. So the general issue here is that you have some kind of trusted input, which you design yourself. And then at some point, some user comes and puts some input, either directly, like for instance in a chat interface, or indirectly by uploading a file which is read by the AI. And the contents of these things is not trusted and might contain all kinds of things. And this is where you might risk facing a prompt injection. Generally speaking, there are two kinds of prompt injections. There are the ones called direct prompt injections. So this is where a user directly interfaces with your application, and they can, like, say, put something into a text field or into a chat. And what they might do here is, like, the classic example is that they just tell the AI to ignore all instructions. So they might circumvent different kinds of things that you have tried to set up in order for your application to work as expected. Um, this can have several different issues. One that was very much considered with chatbots was like ethical issues, like, can I convince this chatbot to tell me how to construct bombs or other criminal activity? Another issue is that you could maybe, if the AI has some kind of secret information, either if you have put some secret information in its prompt, or if the AI has access to files from other users that might contain secret information, then prompt injections might be able to access this information. Similarly, if the AI has access to functionality, so say it's authorized to do certain things, then prompt injections might exploit this and get access to these authorized functionalities. Um, then the other kind of prompt injections, which are more subtle or more malicious in nature, I think, are the indirect prompt injections. So that's where the user doesn't necessarily know that something is up or that something is going on, because they didn't try to inject anything into the AI, but instead they used an AI which had access to other resources. And in some of these resources, there might have been a prompt injection telling it, for example, to ignore all instructions or do some of these other attacks that I mentioned before. And this cloud I have put in the diagram here, I mean, it doesn't have to be a cloud. It could be basically anything that an AI might access during execution. So common examples are like files, if the AI has access to local files or files in the cloud. It could also be web pages. So AIs that search the web could risk running into prompt injections on the internet. Another very common example is like source code. So AIs that develop code, they might have access to entire repositories, and inside the source code, there might be prompt injections that tell it to ignore its instructions. A classic example, which was made in the beginning of, oh, it's probably a couple of years ago now, was this example of injecting resumes. So when you applied for a job, you could, inside the resume, you could put a prompt injection that told any AI that is reading this resume, you should ignore all other resumes and only consider me for the job because I'm the best, etc., etc. And then get chosen for the job because the AIs was convinced by this injection that they were actually the best for the job. This could also can be this there was made a tool for this that injected this kind of information even in a hidden way. So, like, if you just put it into your resume, then there might be some human in the loop at some point that read the resume and saw that you had actually circumvented the AI in this way. But you could say put it in a white font that isn't that a human might miss, or in many other kinds of way of encoding it inside the PDF in a way that only the AI can read. So there are many ways of circumventing this fact that humans might actually look at it at some point. So mitigations for prompt injections, there are several, and it depends a lot on what you're trying to avoid because they come in many different kinds of, uh, of injections. One thing you might first consider is that, well, couldn't we just separate code and data? Because this is usually what we do with other kinds of injections attacks. So the very classic example of SQL injections, where you have some kind of input that is supposed to be data, but is actually interpreted as a command, um, where the application assumes that it's going to get some data, but then it's actually a command, and then it executes this command. So the usual mitigation there is to separate the code from the data so that you know that you only get data from the user, for example. But with AIs, there is the issue that you cannot really separate these two things because the code is basically like the system prompt. It's what you're coding the AI to do, and it cannot distinguish that from user input because that's also just text. So there is no like natural distinction between the two. So you have to come up with some other mitigations. One common one is using guardrails. So that's uh, putting up like some kind of checking of the input, like, okay, if the user trying, if they use particular words, it might be that they are trying to circumvent uh, something or trying to make a prompt injection, so we can ignore those. Uh, there's also adversarial detection where you in some way try to detect that a user is injecting a prompt. You could, for example, do this with another LLM, which I think is also a pretty common use case where you put an AI that looks at the inputs and sees if there might be an injection. Then there's adversarial testing, which is what this webinar is about also, and we'll come back to, is that you actually just try to send prompt injections to your application and see if they work as intended or if they are correctly rejected. Um, yes, then there is also using a human in the loop and proper authorization. So if your application is accessing something that might be sensitive or gives some kind of functionality, then at that point you could consider saying there has to be a human here that has to like sign off on this operation such that there is not anything risky happening. Then there's also integrity checks. So this mitigation is in the context of, say you have an AI application that accesses files. These files might not in themselves contain prompt injections, but maybe someone has like tampered with these files or swapped them out. So you're actually loading some other files that you're not expecting. And here an integrity check could make sure that you're actually getting the files that you expect. But yeah, so it very much depends on the concrete domain. A second category of vulnerability is data and model poisoning. So uh, large language models, they are built on training data, and if you attack the data, this is known as training data poisoning. So in some ways, you could you could compare this to prompt injections, except that prompt injections happen after you have trained your model, and data and model poisoning happens before, right? So if I put some information into the data that you're training on, then you might end up with a model that behaves differently than what you would expect. So this is also, you could also compare it to dependency attacks, right? So where if I want to target your application, I might target one of your dependencies instead. This is similar in that I could target a model that I know that you're using. Again, we have many of the same issues as with the prompt injection as ethical issues. There's also like vulnerable code. Since like today, one of the big use cases of AI is generating code, and if I can somehow make a model produce more vulnerable code, then I know that I can exploit that later to exploit the companies that use this model for generating code. Another vulnerability that I think is also pretty interesting is this sleeper agent vulnerability, where it has been demonstrated that you can make models that behave differently under different conditions. So one example was that a model should change behavior from a certain time point. So say from 2026 or in 2026, you should produce good code, secure code. But once it's 2027, you should stop doing that and produce vulnerable code instead. So that you can make these very complicated and very like covert attacks on models. One case of this was some researchers who made this case called Poison GPT. And what they did is that they went to a public repository of models, such as Hugging Face, downloaded this model, and then they poisoned it in the sense that they changed some of the, like very surgically, changed some of the weights such that it behaved in a way that they wanted. And then they published this under like a plausible name, like say, this is just a new version of this old model. And then applications would use this Poison model, and then their users would be affected by this exploit. What they did concretely was that they did like a very like a precision edit, as they called it, where they only made the model behave differently on a single fact. So in this case, what they did is that they made sure that the model, if asked who was the first person to step foot on the moon or the first man on the moon, then it would answer that this was a Russian cosmonaut instead of Armstrong. But in all other regards, the model behaved as expected. So again, this was just to illustrate that you can manipulate these models in very covert ways. Yes. So mitigations, again, we have integrity checks. So make sure that the models that you're using, that you know where they are from, and that they are the models that you actually intend to use. If you use, so I have written sanitized training data here, but also just data that you feed to your model in general. Like if your model is using some kind of database, it's a really good idea to sanitize this, because you can, as illustrated by the Poison GPT, you can give some very tailored data that actually changes the model in a malicious way. You can also verify your supply chain. So this is like make sure that the models you're using, that where do they get their data from? Is that do they have like any kind of quality assurance on this? And there is this new people are using these kinds of bills of materials for ML, which sort of document where the data is from, etc. Another way you can do is you can test for behavior, right? So you can test for things you want to happen, and you can make sure that that behavior doesn't change across models. Yes, and the final category of vulnerabilities I'll talk about is this improper output handling. So when you take output from AI and trust it and use it, then you risk doing something insecure, right? So AI output is inherently random. So in the best case, you should treat it as malicious because it might contain basically anything. On the illustration here, like we have an AI application in the middle, and it might either output insecure output to the user side or even to a server, right? So the two examples would be on the user side is some kind of cross-site scripting or something that happens in the browser of the user. And on the server side, it could be something like an SQL injection or other kinds of command injections that exploit the backend. One case of this vulnerability was this thing that was coined slop squatting, which was that you could you could figure out what kinds of packages. So when doing software development, right, when the AIs they use packages, um, slop squatting refers to the fact that you could figure out what kind of packages were these AIs hallucinating. So which ones were they suggesting, even though they didn't exist. And then you could squat on these packages, so you could implement malicious behavior in them. And yeah, so as the Twitter here defines it, right? When an LM hallucinates a non-existent package name and a bad actor registers it maliciously, the AI brother of typo squatting. And one obvious question here is this possible? So is there like, can you consistently do this? Can you figure out what kind of packages are like consistently hallucinated? And this was illustrated in a paper called We Have a Package for You, where I have this graph here, which illustrates that so the numbers are like how many times they manage to get like consistent hallucinated packages. So they could find some name that they could then squat on and implement some kind of malicious code. Yeah, so in the relations to the improper output handling here was, of course, just using these packages without checking that they were actually non-malicious. So the way you mitigate against this is that you validate and sanitize the output from your AIs. Generally, if you treat the output as malicious, such that you don't just assume that it is good mannered. And another point is label data when storing. So if you use the output from your AI to uh, like to feed back to it at some point, then labeling this data as AI generated, make sure that you don't sort of forget that it might be malicious or it might be have some kind of issues. Particularly for this slop squatting example, of course, you can also use traditional things like dependency checking and just manually inspect that the dependencies that the AI is suggesting are actually valid and sort of good packages that are generally used by other developers. You could, for example, check that it hasn't been implemented within the last 2 weeks or something. That might indicate that there's something malicious going on. Good. So this was a quick overview of some of the common AI vulnerabilities that I think are the most important, most seen vulnerabilities. Next, I will go through an example of AI vulnerability, which is both in the category of a prompt injection and in the category of improper output handling. So the way you do this attack is that if you know that at some point the output of the AI will be displayed in a browser, for example, where explicitly it will be displayed as Markdown, then you can inject like this kind of an image that the browser will then look up, maybe on some server that you control, and if it then puts a query parameter here, p, then you can exfiltrate information from the session that the user is having. So in this case, you could replace this p with some kind of sensitive information. So what happens is that you inject this thing into some kind of document, for example. Then the user interacts with this chatbot, and because it has been told to do this thing, then when the user interface renders the markdown, which the chatbot has generated, then it will exfiltrate this sensitive information. So concretely, I have this video of trying to do this on ChatGPT. I made this a while ago. I have this. Oops. Yes, here I have description of Niels Bohr, which I want to have summarized, and I don't notice here that there is an injection in the bottom of this text. Here I put it in a white font, for example. Then a user might paste this into into ChatGPT, and here the test 123 represents some kind of sensitive information that I don't want to have disclosed. And then they paste this text that they want to have summarized. And since there is this injection, then ChatGPT does as it is told. It inputs this. Sorry. It inputs this image in the Markdown, which is rendered by the browser. But you can also see here it's a bit small here, but you can see that the P query parameter here has been set to this test 123. So when this image is downloaded, then this GET request is sent to this malicious server, and you have exfiltrated this piece of data here. So this is one kind of issue that you might face, right? That you want to display Markdown, for example, and you want to be able to get all kinds of different texts, but then you do actually risk something like this happening. So mitigations for this is I think the most obvious one is don't render this kind of Markdown. You could, for example, just display plain Markdown, then you wouldn't have this issue of actually making the GET request. Another traditional security mitigation you could make is something like content security policy. So make sure that the browser doesn't make arbitrary requests to other websites. And in general, you can use the mitigations that I mentioned previously under prompt injection and improper output handling. So the improper output here that you're handling is the summarization from the AI, right, which contains some malicious output, namely the request to the malicious server. Good. So this was an example, and now we go into the testing tools. The testing tools that we have looked into in this project are what is usually called automated red teaming tools. A red team is a group of people who act as an adversary and try to compromise or exploit a system simulating an attack situation. Concretely, these test tools, they are then automated red teaming, so they just try to send malicious prompts basically to the application and act as some kind of adversary. The first tool we tested was this tool called Garrick, which is a large language model vulnerability scanner, which basically consists of a simple CLI tool, which you start, and then it tries to send some prompts to a defined endpoint. And it's based on these probes and detectors. So the probes are the malicious prompts. So it might be, for example, the one that I just shown in the example before, and where it tries to make to get the AI to output some kind of markdown with a URL in it. And detectors, which are then some kind of evaluations of the output from the AI, which classify if the attack was successful or not. So these detectors can be pretty basic, right? It can be just look for a word. I don't want my chatbot to talk about guns, so I look for the word gun, and then if it is there, then it's a hit. But the detectors can also be more sophisticated, like they can use AIs to look at the output and see if the attack was successful. So Garrick here consists of several of these probes and several of these detectors. There are several options you can use for this tool. In general, this tool was made to test foundational models, so think like ChatGPT or Claude or these kinds of models, but you can also make Garrick target your particular application, which was what we did in this project here. To do this, you need to configure it to your particular endpoint, and this is pretty simple. Like here is an example configuration. So you just give it the URL. It could be, for example, a chat interface that you provide. Then you usually have to give some kind of headers, right? Because, for example, there might be some kind of authentication that needs to happen, and here you have to put some kind of authentication token. This can look very different from application to application. It might also be unauthenticated. And then you have to put this $ input somewhere. In this case, it's because the thing that you're sending to your application is a JSON object, so you put the input in this JSON object. And then what Garrick will do is simply it will put the probes, like it will combine the probes with this configuration and put them in, try to interact with your application and see what it responds with. There are several of these probes implementing Garrick. Here are some of the ones that I think are the most interesting, or that we try to do right. So there's the do anything now probe, which tries to do this thing where it tries to circumvent the actual purpose of the application. Then there's web injection, which is precisely the exploit that I presented in the example, and also probes trying to exploit in different kinds of encodings. So maybe your application knows that someone might try to to circumvent some guardrails, so it will reject it. But if you encode this thing into some kind of other language or some other format, then you might be able to circumvent these guardrails. One example would be base64. Another more basic example would be something like NATO, so the phonetic alphabet, right? So instead of just writing messages, I write alpha, unicorn, whatever these are. And since the LLM is pretty clever, then it might understand this encoding. And at the same time, this encoding might circumvent the guardrails that you had intended for regular speech or regular text. Then after you run these probes, you get a report, and here is an example report from one of the tests that we ran on Risk Finder. And here you have exactly this. So it says here it says probe web injection markdown image exfil, which is precisely this exploit that was demonstrated in the example. And there we've managed to find that this did actually work, right? So in this application, it was possible to make it supply some markdown with the URL where you could get some sensitive information out of the session. Yes. Another example that another tool that we tested in the project was a tool called PromptFoo, which is a framework for both automated red teaming and general evaluation. So red teaming is where you try to test your application for security issues. General evaluation would be more like testing for quality, so making sure that it responds properly in the context of your application. PromptFoo has a lot of similarities to Garrick, but it has some other features. For example, part of it is that it generates targeted prompts, right? So instead of just trying static probes, as they were called in Garrick, it actually takes as input some kind of description of your application and then tries to make targeted prompts. So in this way, it acts a bit more like a human red team would do, right? It tries to exploit some kind of distinguishing features of your application. Yes, and it has this web interface, which is very nice. Here you set up your target, very similar to the configuration I just showed you from Garrick, right? You write some kind of HTTP requests where where should it try to send the probes, and how should it expect to pass the response? How is the response supposed to look? And somewhere here you write, like here you this kind of syntax, right? You say bracket prompt, and this is where it will then put the probes. Then you give these application details so that it can make these targeted prompts. Then you choose plugins, which is the same as probes from before, right? So which kind of probes do I want to run? And finally, you tell which strategies to use. So how many many times should it try to send these malicious probes before it has insufficient coverage, say. And finally, you get some kind of evaluation on, okay, so how many tests responded, like how many tests was good and how many tests was bad. Yes, so a very quick comparison of these tools and some considerations in general. The ease of setup, I would say the Garrick tool is very easy to set up and very easy to run in, say, a CI, because of this is a CLI based tool. Of course, you can also do this with PromFu. So they are in those regards very similar. One thing you should worry a bit about, which we also worried a little bit about, was how many tokens do these tools then use, because they will actually send a bunch of probes, right? So if you set the amount of probes to be very high, then they will use a big amount of tokens, which might be an issue depending on exactly how your application is set up. Yes. That was all from me for now. Then I will hand over the microphone to my co-host from the two startups. And first is Panos from PrivacyMate, who developed the product Hipaco.
Awesome. Thank you, Benjamin. A little words about myself. Again, my name is Panos. I'm the CTO of Hyperco, which basically means I'm the guy behind the code of our product. And we develop this agent for digital compliance. So our clients is mainly lawyers who work with GDPR and other security type of legislation like NIS2 and DORA. And they perform like privacy and security assessments, mainly in Word or in other different governance, risk and compliance platforms on the web. What I have to say is that, my background is actually cybersecurity. So I used to be a pen tester, and I was also doing a lot of code reviews before I start my startup. And we see a lot of changes when it comes to how we defend now these new types of architectures where AI and in particular LLMs are involved. So even though, I had the experience with traditional type of security when it comes to software, the project really helped us a lot to get knowledge around this new stuff that go on here. And actually also we tested our application, and Benjamin found one vulnerability there, the one that he explained around rendering of prompt injection, basically, where you can exfiltrate data. And I think the biggest lesson for me is actually to shift my mindset from thinking, well, okay, we need to protect against prompt injections, to there is a prompt injection, and what can we do about that actually? Because every interesting application out there that uses a large language model potentially has a prompt injection. If you're doing something interesting, you're potentially vulnerable to a prompt injection, either through a file that someone can upload, the web, as Benjamin showed. So there will be a prompt injection. So the question is like, what can happen with a prompt injection? What the attacker can do? And shifting your mindset to this can sometimes simplify things a lot. So for instance, the vulnerability that Benjamin found into us, it was actually in the rendering engine, in the UI, because there is the prompt injection, and then the way you render the output of the LLM causes this data exfiltration, because the attacker can actually inject arbitrary kind of JavaScript, HTML, and can throw some data outside of your context. So then you fix the rendering engine. And I think for me, like the biggest takeaway, and something that is potentially useful for you guys as well that you are watching, is shift your mindset to protecting and starting to think about all the edge cases of the prompt injections to, okay, there is a prompt injection, that's the threat model, what the attacker can do if they can actually give arbitrary instructions to the LLM. What can they do? What can they access, like files of the user and then exfiltrate them to their server? What can they do? And then start thinking about how we can protect against the second step. I think that's the biggest lesson for me, and that's how we approach a lot of the security stuff that we do in our startup. Yeah, that's me. Thanks, Benjamin.
Thanks you, Panos, for the nice insight. I really agree that it's a good way to think about it. There will always be a prompt injection. The question is how severe it is, I guess. Then next up is Emil from RiskFinder.
Yeah, thank you, Benjamin. I'm the founder of RiskFinder, and RiskFinder is building AI-powered business continuity management for critical infrastructure. And this is about assessing risks to essential services. This is water, energy, transport, and that is what we call critical infrastructure. And this is a regulated industry, and security really matters in this space, of course. And this is also why security was or is important to RiskFinder. And what's interesting about the Markdown thing is that we in RiskFinder in the platform, we don't render the Markdown. So that was another way of doing it, but it comes with the trade-off of having a worse UI than with the Markdown. So this is this constant understanding of, okay, what's the trade-off if I implement this in relation to the security as well. And RiskFinder is a early stage startup funded by the Innovation Fund. And of course, AI brings a lot of new opportunities. That's of course why we're in the space, because it can do something differently. But as a early stage startup, you don't have these unlimited funds. So we need to scale our security testing to match the state of the company. And this was a great project for us as well, to have Benjamin and a colleague help us identify, okay, what's actually the best approach to where we are at the moment. So this is a good and cost-effective way to use these tools, because we can do the initial risk assessment if we have a new feature and say, okay, this problem that we are trying to solve, it could actually be solved better or faster in a new way using AIs and LLMs. And then we do the risk assessment and say, okay, we actually think this is a good idea. And then we can test the implementation afterwards, saying, okay, we've done the assessment and now we have tested it with the use of these tools. And we can see either if we identify something that we need to go and fix, or we can say, okay, we passed the test. So for now, we think this is a good state of this feature and we can implement it to the final platform. So using these tools have actually been easy. They are easy to understand, and it's a good way of mitigating some of the issues that you are identifying. So good experience for us using these two tools, and of course also some of the risk assessments that goes before them. Yeah.
Cool. Thanks, Emil. Then I will go on to a bit of an outro. I hope that if you have some questions, please write them in the Q&A. Then I think we have time to answer them. So yeah, here's just the contact information for me. Another thing that I would like to mention is that, as Emil also pointed to, in this project we did several things. So one aspect was this testing tools for AI applications. Another part of the project was doing threat modeling that was specifically targeted towards AI applications, where my colleague Saruhi looked into some new threat modeling and risk assessment tools for AI applications. And she did this both also in collaboration with Panos and with Emil, and will at the end of February, I think, give a webinar about this, where she will talk about the threat modeling of AI applications. That was the words. I don't see any questions. I don't know if you can get like 15 seconds more to write something. Otherwise, I would just like to say thank you for attending, and I hope you got something out of it. We will send out the slides, and the video will also be uploaded online in the coming days. So thank you, and thanks to my co-host also. Bye.
Bye.